Have you ever looked up into the night sky and wondered why it is dark? If there are literally billions of stars out there, because from what I can gather, stars are supposed to emit light. They do that, right? That's because according to the most recent measurements, the observable universe is only about 94 billion light years across. And while that may not sound like a lot compared to, say, the estimated 100 trillion people who have ever lived on Earth, it's actually an incomprehensibly large number. After all, 100 billion is 100 trillion times greater than 1 million, which is already a lot. Just think of trying to count to 100 billion. It would take you more than 3 million years. Imagine you're at a party with your closest friends, and all of a sudden the room that you're in begins to expand. That is because the light from stars is very easy to detect when it is passing through empty space. However, when it encounters matter of any kind, it will either pass straight through or bounce off of it. This is called scattering. At first, you might think that the walls are stretching, but soon you realize that the entire room is getting bigger. Take our nearest galactic neighbor, the Andromeda Galaxy. All of the light coming from that star has had billions of years to be scattered by dust and gas. And so it's incredibly difficult to see anything other than a faint blur, even though it's only 2.5 million light years away. Its light is so obscured by interstellar dust that it looks like a fuzzy blob through Earth-based telescopes. This is why we can only observe the universe back to a certain point, known as the cosmic microwave background. You see, stars go through multiple life stages before becoming white dwarfs, neutron stars, or black holes. However, they're also really big, so their light is often blocked by clouds of dust and gas that surround them. In fact, some astronomers believe that a significant portion of the cosmic microwave background radiation comes from red giants. You see, even though stars are mostly empty space, they still have a lot of mass, and all of that mass creates a strong gravitational pull. That gravitational pull is so strong, in fact, that it prevents light from escaping the star's core. And some of those stages are not very good at emitting light. It's not because they're particularly good at absorbing light, but rather because they're so dense that no light can escape their gravitational pull. Any light waves that have been stretched past the wavelength of visible light are invisible to us. That's because even if there weren't any dust or gas in the universe, the light from stars would still get blocked by the stars themselves. You see, stars are really big, and so they would completely obscure the view of stars that are behind them. And second, the universe is really big. Those two facts alone make it impossible for us to see most of the stars in the universe. Well, that also plays a role in why space is dark. You see, as the universe expands, the wavelengths of light get stretched. Stars also block light by casting literal shadows. On the one hand, this doesn't really make sense because stars are just balls of gas. But when they're close together, they block your view. It is a truly remarkable phenomenon that reminds us of just how small we are in comparison to the vastness of space. Thanks for watching. The same is true of stars. So even if there were no dust or gas in the universe, we still wouldn't be able to see most stars. So how can they cast shadows if they don't emit light? Well, the answer is that they do emit light, but it's just not very much. As the ambulance approaches, the waves of sound get compressed, which raises the pitch. But once it passes, the waves stretch out, which lowers the pitch. Light works the same way. That means red light gets stretched into even longer wavelengths and eventually becomes invisible. This is called the Doppler effect. It's so bad that you can't even make out individual stars within the galaxy. That's what's happening in the universe. Everything is moving away from everything else, and the universe itself could be infinitely larger than that. But since we haven't discovered any evidence of a universe beyond our own, we'll stick with the observable one for now. When light passes through the atmosphere of Earth, it undergoes a lot of scattering, which is why the sky is blue during the day. That's because blue light gets scattered more than red light does, which is why you see a blue sky during the day. But when the sun dips below the horizon, you get that beautiful red and orange glow. That's because the light that reaches your eyes has had to pass through more of the atmosphere, and so most of the blue light has been scattered away, leaving mostly red and orange. So if they're emitting light, and there's a virtually infinite amount of them, then shouldn't the universe be filled with an almost blinding light? As light from stars travels through the universe, it collides with dust and other particles, and those collisions cause the light to scatter. Now, if the universe didn't have any matter in it, then that wouldn't be a problem, because light would just pass straight through the universe unhindered. But unfortunately, the universe is full of matter. You'd think so, right? But the universe isn't like that. And today we're going to show you exactly why. You see, for the sake of argument, let's assume that every single star in the universe was a perfect point source of light. In other words, they emitted light equally in all directions without giving off any heat or radiation. If that were the case, then the universe would indeed be blindingly bright. The first thing that you need to understand is that even though the observable universe only contains 100 billion or so stars, the actual universe likely contains an infinite amount of stars. See, the universe didn't just pop into existence fully formed. Instead, everything we see today began with the Big Bang, and since then, everything has been expanding away from each other. And by expanding, we mean moving through space. So we know that the number of stars in the universe is at least 100 billion. With that much mass, you'd expect there to be a lot of light, right? Well, yes and no. But unfortunately, things don't work like that. And the reason why has to do with the age of the universe itself. To be clear, space itself is expanding, not just the stuff within it. Think of it like this. At first, that might not seem like a big deal, but over billions of years, it makes a huge difference. And when light bounces off of particles smaller than itself, like dust or molecules, it's called Rayleigh scattering. Okay, so where was I? Yes, the universe. In fact, there's enough matter in the universe to obscure the light from most stars, especially the ones that are billions of light years away. Now imagine trying to look at a star that's 10 billion light years away. Now remember how I said that the universe is expanding. If you've ever heard the siren of an ambulance approaching you and then passing, you've heard the Doppler effect in action. And as the universe expands, The light from distant galaxies gets stretched so much that it's no longer visible to us. Another thing to keep in mind is that the light from stars isn't just being absorbed and scattered by dust and gas. It's also being blocked by the stars themselves. For example, red giants are known for being incredibly luminous, meaning they emit a tremendous amount of light and heat. Of course, it's not just the dust and gas that blocks light. Any light that manages to pass through the star's outer layers makes it all the way to the core, where it gets obliterated by gravity. This is why neutron stars and black holes are black. Now, this might all sound like a lot of mumbo-jumbo, but it all boils down to simple facts. First, the universe is really old. In fact, even if the universe didn't expand, we still wouldn't be able to see most stars. It's like trying to see through a forest. When the trees are far apart, you can see pretty far. We hope that this explanation has helped to clarify why the night sky is dark, despite the almost infinite number of stars in the universe.